So we've seen there's not much correlation in that data set, but still what can happen is that individual values for one variable can impact on other variables. And ideally we'd like to visualize that, but we can't really visualize all 5 dimensions. Okay, and one way of doing it with just 3 dimensions is to use a thing called a bubble plot, which is like a scatter plot, like we've seen a couple of weeks ago, but it uses an extra bit of information to convey more sense about the data. So what do? We can use it to compare 3 variables, and we use 2 of those variables to do the scatter plot. So a standard scatter plot using 2 of those variables, so maybe price versus cost, as we saw just now. And then we can use the size of the dots to set them to be proportional to the values of the 3rd variable, whatever that variable is. So that will give us the bubble. So the bigger the size, the larger the value of that variable for that particular item. So that's a typical bubble plot. Okay, it's in fact, I think it's, if I go back, I think it's this scatter plot, this particular one here. So it's cost versus price, but you can see that the bubbles here are conveying extra information about something else. So as I say, if you have a bubble plot of a variable u versus another variable v versus another variable w, you'll have the bubbles will be in the same position as a scatter plot of u versus v, but the bubble size is governed by the variable w. So let's see an example of that and see what that can tell us. So if I just, I think the one I was just showing you is price versus cost versus profit. So those things are kind of closely related. Let's see if we can get any information about that. And in order to do a bubble plot, you use the same code that we did for scatter plots, but you need now to set the size of the dot. Okay, so first of all, and you don't have to do it this way, but this is a good way to do it, is just to add another column into your data frame, which I'll call bubble size, and we set it to some. We're doing price versus cost versus profit. So price and cost are going to be on the axes, the x and y axes, and profit is going to be the bubble size. So I want to take the profit, and I want usually have to scale that by something. If I just set that if I set the bubble size to be the profit, normally that's not going to be big enough, and the bubble size, they'll just be tiny dots. So I need to scale that by something. So I have to pick a value. Here I've picked 20, and that's just done by trial and error. I don't think there's a standard formula for finding a good bubble size. Then we do the scatter plot, but the difference is here I'm setting the bubble size. S sets the size of the dots, and this can be done differently for every dot. Can be just a number. You can just set the bubble size as we've done before to be 10 for everything. But here, because I'm giving it a column of the data frame, then every bubble will have a different size. I'm also setting transparent so that if we have more than one bubble in the same place, we can see that. I'm also, just to help understand it, I'm labeling the bubbles using the annotate code that we saw. Was it last week? I think so. In their outliers. You don't have to do this. That's not part of the bubble plot, but it helps to understand the data. So the bubble plot is just essentially just this line of code, but with calculating the bubble sizes. This is the annotation that we saw last week, where I'm just labeling each dot with its the name of the product that it corresponds to, and also I'm also adding a line like we did last week, where we can show where the price and the cost are the same. So hopefully that will be nowhere. Okay, so we're not expecting the price to be the same as the cost, because that would be zero profit for the company. Although it's possible that they might have things where they sell them as loss leaders, in which case the price would be less than the cost. But that will give us an indication of where that break-even point is. And that's what you do if you run that code. Actually, I'm going to run that for real, just because it's just a bit too tiny to see on the slide. That's the picture you get. So I've got this red line indicating, there we are. That's better, isn't it? I've got this red line indicating where price equals cost. So that's just, you know, where if the price is 10, then the cost is 10, so on. As I said, I'll make this as an observation on here. Yeah, first of all, everything is to the right of the line. If a product was to the left, that would mean the cost is greater than the price, which is a negative profit, but which is, you know, that could be done for what are called loss leaders, where you try and sell something at a really cheap price to bring people into the stores, but there's none here. Okay, and the other thing is, perhaps it's clear on this, can you see something about the bubble sizes? Can you see that the further away from that red line they get, the bigger they get? So you might say, well, is that telling us something interesting? In fact, it's not. Okay, it's inevitable, because if you think about any fixed cost, moving to the right is equivalent to increasing the price. Okay, let's look at an example. So if I think about this K, the price, the cost there is, I don't know, about 15. Let's say it's about 15. The price is slightly higher than that. It's maybe 17. So if I just carry on this line, so go to the T one and the A and maybe further along, as I get further away, the price goes up. So T, I guess the price is maybe 18, K is 17, T is maybe 18, A is maybe 22 or something. So as I move in a straight line away from that red line, so I'm moving a straight horizontal line away from that red line. There's no other data along there, but you can see the idea. As I move further and further away, the profit gets higher, because the price minus the cost, the price that the customer pays minus the cost is the profit, so the profit goes up. And so therefore, you would expect, as you go further along a horizontal line from the red line, as you go further and further away on the horizontal line, the profit would go up, and so the bubbles would get bigger, because the bubbles are showing us the profit. So actually, although there's a pattern there, it's not actually telling us anything that we couldn't have figured out already. So, and it's the technical reason why that's the case is that these values are codependent. So if you know any two of these values, if you know the price and the what do we know? We know the price and the cost. We can calculate the profit. But if you know the price or is it the other way around? We know the price and the profit. We can calculate the cost. If you know any two of them, you can calculate the other one. So they're called codependent. Okay, that's our first bubble plot, but not it's kind of showing us some information that's showing us there are no loss leaders, but it's not showing us anything very much more than that. So I'll finish the video there, and then we'll move on to another example.